Hey there, everyone. It's good to see you again. My name is David Hoelzer, just in case you weren't with us for one of our previous live streams. And I'm a fellow with the SANS Institute, but what I'm really here to talk about is this week, continuing on in a project that we got started. We're trying to see if we can marry Python and TensorFlow with the output of Zeek. I don't know about you. I don't know how many of you are currently using Zeek, but it really is a phenomenal tool when it comes to getting information about things happening within your environment. And while it produces very rich logs just on its own, I'm very interested in using it to do real-time classification of activities on my network. And that's really what prompted this. And, I can give you a little spoiler. It works. We can do that. But we're seeing if we can just build a little bit of that together and explain some of how this works and how to establish communications between Zeek and other tools, in addition to introducing a little bit about TensorFlow and some machine learning. So now, if you were here the last time, let me just turn back to my desktop here. When we left off, we had managed to get this much of our code working. What we've done so far is worked out how to create a Zeek broker communications channel. So that's actually happening. Let me just pull that on the screen here. That's happening in our what did I call that? Comms.zeek. I think that's where it is. Here it is. And I'll tell you what, let me just, yeah, there we go. We'll just bring that so it's the only thing on the screen. And this allows us, whoops, that's the wrong one. That's the Python script. Let's try that again. Comms.zeek. There we go. This allows us to establish a broker communication channel. And then over on the Python side, we can subscribe to it. And what we managed to do last week was just a proof of concept showing the channel was functioning and reacting to DNS messages and just publishing DNS messages out to the Python side. And I've actually got that running over here in the Jupyter Notebook. And you can see our TensorFlow content coming back. Or I'm sorry, not our TensorFlow content. That is the name of the channel. Our broker data is coming out over here. Now, you may notice things are just a little bit different than the last time we were together. I've only made one little change because last time, before the live stream, we were having some upgrade issues with a dev sensor. So I actually used a virtual machine to work through the live stream. But at this point, we've now stabilized our dev sensor. And this is actually now running over on one of our dev sensors. So I've actually migrated this over there. And I just did a little tinkering here. This is unfamiliar code that you haven't seen before, where I'm doing a little check to see what kind of node type this is running on. Now you'll notice this code is currently commented out, and I don't want that to distract you, but I do just want to point it out to you, because as we develop our proof of concept here, we are eventually looking to see if we can get this deployed into a running Zeek cluster. And then see how the thing behaves. So that's really where we're heading. Hey there, nice to see you, Daniel, from Colombia and El Salvador. Where else have we got people from? Nice to have you here, Kenny. I am interested what countries are here and our information. I did a little sort of research. It was very informal, anecdotal research about what the best time for a live stream was. I was really surprised that Friday at about noon Eastern time was apparently the best time to have a live stream. So I am kind of curious if you've got any feelings on that. Is this a good time for you? Or, I mean, if you're here, I guess it is. Or is there a better time? I'm just kind of curious. I'm not really looking to move it, but if most people ask for a different time, we might do that. Hey there, hey, Mohammed, I know you were here the last time. Newport News, nice to have you, Daniel. And Jerusalem, fantastic. Portugal, Arizona, Quebec. My goodness, that is absolutely fantastic. In any event, when we want to move this over and make it part of something that runs in a cluster, we are going to have to deal with the different kinds of nodes. Because if I push this into the cluster, it's going to try to run on everything in the cluster, and everything is going to be listening on port 9999 on localhost. So in the long run, we're going to have to do a little tinkering there. And what I sort of have in mind, I'll just tell you what my plan is that when we get to that point, probably in a couple of streams, what we'll likely do is have the workers aggregate that data back to either the manager or to a proxy And then the proxy is the thing that we'll talk to using our Python. But we don't need to deal with that yet. I've just got a little bit of kind of stubbed out code there just to remind myself of that issue. Otherwise, this is the same. And I've also brought over the code here and just put it into our Jupyter notebook. Before we go much further, though, I'm actually going to switch over and I'm going to be working with my terminal for a bunch of this stuff because I feel like there's some stuff we need to get straight with our Zeek code. So let me just, I'm going to start up Tmux here. I don't know how many of you use Tmux. Any Tmux fans out there? Hey, nice to have Bucharest. I'm not sure I saw you the last time. We've got Berlin and India. Fantastic to have you. I use Tmux a lot. I find it's just wonderful for managing my console because I'm constantly opening up lots of windows. Hey there, Edinburgh. I've always got to work on that one. We were corrected when we went to visit because, of course, in the US, we pronounce names just a little bit differently. Anyway, I am a fan of using Tmux, and I'm just going to open up here using Emacs. You know, I know about all the editor wars. I am an old school Emacs person. I've been using it for 30 to 40 years. It's been a long time now. But let me open up comms.zeek because we need to do a little bit of surgery on this thing. What we did, we built something that would generate this event. And right now our event is putting out the originating host and all this stuff and a DNS message. And in the end, we're not really trying to get a DNS message out of this. So what I want to push out is going to be packet content. I'm not going to worry too much about that just now, but we are going to have to fix that. So maybe I'll just put a little to-do in here, change to packet content, because before I can actually add that in, I need to get the packet content. So let's figure out how we can do that. And I'll tell you what our main goals today are. What I really want to get done today is manage to extract packet content or stream content really out of TCP streams. And I'm going to be trying to extract out what the client is sending. Now we can separately pull out what the server responds with, but I'm interested right now in what the client is sending because I want to identify that protocol based on the request the client makes. So I need to get that data out, and then I want to send that over to my Python script and convert that data back into something that I can do some machine learning with. You'll see why that's a little bit of an issue as we proceed through this. So that is something I have to do here. I'm going to leave my Zeek init alone. I think, however, we are going to get rid of our DNS message because that's really not what we're going to be generating. Instead, I want to capture the first X number of bytes of stream content. Oh yeah, I am a huge Tmux fan. I've been using it for a long time. And in fact, I'm curious, has anyone found a great way to remember all the shortcuts? I mean, I sure haven't. I do have a couple of quick refs, but I'd really love to find, like, I don't know, something like a kneeboard, like you'd have if you were an aircraft pilot, just a really small one, because I really can't manage having these huge quick refs floating around. So if anyone's got a pointer for that, I'd sure be interested in hearing about it. Hey there, nice to see you from Singapore. I think you were here the last time too, weren't you? In any event, in order to get the beginning of that stream, I think what I'm going to react to is going to be the TCP packet. The TCP packet event is going to be generated whenever TCP packets arrive. Now, I know that's expensive. In other words, there's going to be a lot of TCP packets, right? That's going to be a pretty expensive event. But we are really still looking at creating this proof of concept, and we can work on optimizing later. And I'm also thinking about the fact that I always run Zeek as a cluster. So if this is just a matter of adding a couple of more workers in to handle this, I'm not super concerned because I'm really not going to do anything very heavy inside of that event. In any event, let's start putting this together. So this takes a connection. It has is orig. In other words, is this coming from the originator? Is that who's generating the event? The flags that are present comes in as a string. The sequence number, and this is actually the relative sequence number that gets delivered to us, along with the acknowledgement number, that is also relative. A length which is the number of bytes that should be in this payload, and then the payload itself, which is that's the thing I'm really looking to get my hands on. Right now, I'm going to comment out that broker piece, and let's just do this to start with. Let's just print payload. And we save that. And up here, because we are just kind of, working things through here, this is how I do my development. I mean, I make a little change, and I'm going to test the thing out. Let's just try that. So I'm going to use Zeek-I, and on this guy here, I've got ENP6 S0F0. So that interface is it's probably got way more data than we want. That is a 10 gig interface coming out of a Gigamon, but I know there's data there. And let's then pass our comms.zeek. Here we go. And whoop, yes, we are getting content. So that definitely works. I am getting content. Now, Zeek is trying to do us a favor here in how it's printing this content out. Oh, okay, my font's a little on the small side, so I can certainly make that bigger. Let me just do this and hang on. I've got to resize my window a little bit, see if we can still fit it in the screen. If I can grab the corner. There we are. Get this up here. All right, I think that'll about do it. Okay. So Zeek is trying to do me a favor here. Zeek is looking at what I'm doing and saying, yeah, you're asking me to print this stuff onto the screen, but you know what? A lot of this is binary content. So Zeek is kind of defending me here. In fact, if you do some digging around, Zeek does this automatically. Anytime you're trying to send binary content somewhere, it is going to render that out, and it converts it into hex, which you can see happening here. And then we've got some printable strings in here too. So we've got $UN. So this is the actual content that's coming out of those, out of that packet content, or out of those packets. But while that works, I don't really want all of the packets. I really want just the beginning of the stream. So let's think about how I might do that. I feel like I could probably take advantage of a couple of things. Let's first say if is orig. So in other words, if this is coming from the originator. If it's not coming from the originator, I don't care. Now, yes, I know that it might actually misidentify who the server is on this because it picks up the conversation late. But you know what? I don't really care about those. The reason I don't is I'm trying to find the application layer protocol headers, and those are only going to be in the start of the stream. So if this stream is found later on, well, I'm going to end up missing that one. And that's okay, because I don't want to start having false reports for things that aren't even the beginning of the stream. So let's say, is it at the originator? And let's do something else. Let's say if flags, how about flags, or I think it's actually like this. Let's see if I have S. I don't want to know what's in the flags in this packet. I want to know about the history of the conversation. In other words, did I see a SYN? Have I seen a SYN in this conversation? So is the S, is the SYN flag found in the ID $history? So the history, is that inside of ID? You know what? I don't think it is. I think it's actually just inside of the connection. Yeah, because it's not part of the tuple that makes up the ID. So the history is the history of all the code bits that have been seen. The capital S. Now, the S in general means, did you see a SYN? If it's a lowercase s, then you're looking at a SYN being sent by the client, or I'm sorry, excuse me, by the respondent. If you're seeing a capital S, that was a SYN sent by the originator. So this should be looking to say, is this a connection where a SYN was seen from the originator, and is this packet coming from the originator? All right, so let's just do that for now. This still isn't quite right, but let's start here. Sorry, I'm a little bit pedantic about getting these things indented correctly. There we go. Let's just save that. Let me just check it again because I do like to just make sure things are still working. Oh, I'm not seeing much happening here, but it could be there's no new connections going on. So let me just try to maybe fire up a web browser here and go out to a website or something. Can't reach that one. Okay, how about go to Google? All right, looks like that worked. Let me just, let's see. Ah, yes. Okay, so over in my browser, I just ran some things, and we were definitely getting some content there. That works. I'm getting less content because it's only looking at things coming from the originator and only if the connection's established or if a SYN was seen. But it's still not quite right. Why isn't it right? Well, think about this. That condition sent from the originator and the SYN was in the history, that's going to be true in every single packet from the originator after the initial SYN. So that's really not quite right. I think what I'd like to do is add another condition to this, because I'd also like to know that this is the beginning of the stream. Now, it turns out that there's a super handy thing that we can use. Hey there, Abdullah, nice to have you. The super handy thing we've got is the sequence. In particular, I said this is the relative sequence number. And for you folks who know TCP super well, you know that in the initial SYN, we're going to send a SYN. That's going to be the 0 offset. And then we have the SYN-ACK and then the ACK. But that's going to now effectively be, I'm at sequence number 1. At sequence number 1. Now, if that's unclear to you, I'm not going to go through all of it. 503, if any 503 fans, anyone here taking 503? Because if you've taken that class, you sure do know how all the sequence numbers work. And I'm looking for the first thing being sent from the client. So I'm going to say where the sequence number is 1. All right. So where the sequence number is 1, but you know, I'm thinking about something else, because it would be like SYN, SYN-ACK, ACK. And you know, there could be other ACKs and stuff going on in there from the client, but it hasn't sent any data yet. So I'm going to add one other check in here. I'm going to say, and what I'd like to look at is the length of the payload. And I do know I have that len thing there, but I'll tell you, I'm not a fan of using that. I think what I'd like to do is grab the payload length. Now, if you're not familiar with this in Zeek, one of the super nice things, you know, it is kind of mathy, and the folks who put this together were mathematicians, so that makes sense. The absolute value of something or the magnitude of something, it actually makes perfect sense that would be, what is the magnitude of that string? What is the length of that string? So let's say where the length of the payload is greater than 0. So let's make those our conditions. Let's start up our Zeek again. And again, I'm going to be kind of behind the scenes here. Let me just open up another browser here and just go somewhere and see what happens. And yes, we are definitely getting content. And you can see that I'm getting way less content because now we are only seeing the bytes at the beginning of the stream. Fantastic. So we are getting very close now. Now, let's see. So I'm having blur issues. Oh, okay. Yeah, that's interesting. So is that kind of a LinkedIn thing? Don't know. So Basil, where is Niam? I'm not really familiar with that. Is there a longer name I'd know? I'm not sure I know that name. All right, so let's see what I've got here. I am now able to pull this data out, and it right now is showing up as these bytes, but there's another problem that's going to come up. I think I'm just going to short circuit the problem now. The problem is that if I try to send this somewhere, so for example, let's say I were to come up here and I were to modify what I'm sending out, in my event. What if instead of making this query, let me change this to content. That's what we'll call this. And There we go. Why is it fighting with me? My Emacs is fighting with me today. There we go. And instead of sending a message, what I'm going to send is the content. I'm going to send the payload. So I'm going to say this is content, string. That's what I'm going to send in this thing. If I try to do that, and I try to send that binary data there, Zeek will absolutely refuse. It will not do it. And that can be kind of frustrating. We took an hour or two to work through this the very first time we tried to do it. It turns out if I'm trying to save it or do a hash of it or a whole bunch of other things, there's no problem. It's binary data. But when I try to put it into a broker channel, it will flatly refuse to allow me to send binary data over a broker channel. That's okay. We've kind of worked out a workaround for that. Rather than just printing out the payload, here's what I'm going to ask it to do. I'm going to instead ask it to do a string to ASCII hex of that payload. And if I do that and restart my Zeek, and whoa, I've got a little problem here. What's my problem near query? Unknown identifier query. Oh, yes, because I changed the name. So let's change this over here to content. Try that one more time. That looks better. And up, and look at that. So now we are getting our data, but notice that it's being rendered out into an ASCII form of hex. It's an ASCII form. That's really important because since it's ASCII, now I can stick that in a broker channel. There will be no problem with that. Okay, fantastic. So let's stop this. And I think what I need to do now is actually get that into my broker channel, right? I feel like that's all I really need to do. Let's just see here. Let me come back down here. And I'm currently printing that. You know what I think I'm going to do? I'm thinking ahead, and I know that in the future, we're also going to grab things like UDP, and I don't know, maybe we want to grab some other things too. I mean, it's not really an application layer, but for example, the content you'd find in an ICMP stream is going to be maybe the echo data for echo requests. So it should be able to classify normal echo requests from other things because Windows and Unix have very particular patterns they use. And then there's some other well-known mapping tools that have things, but other content be super interesting. Maybe there's other application, a covert channel, or some kind of other kind of stuff happening under there. So rather than repeating the code that's used to publish out to the broker channel, I think what I'm going to do is instead abstract that into a function. So to do that, I'm just going to define it as a function, which I know we don't do a lot when we're creating Broad scripts or Zeek scripts, but you sure can. And I'm just going to call this output, and it's going to accept a connection object, and it's going to accept I'm going to call it the bytes, which are going to be a string. And what I'm going to do out down here is I am going to copy this. And let me do output C, comma, payload. Well, actually, that's not quite what I want. C, comma, I don't want to print that. Oops. Let me instead send that ASCIIfied hex out there. Let's see, does that look okay? That looks okay. Whoops, and this is bytes string. That's going to be bad. And let's then just for now, let's just print C, comma, payload. And let's just, make sure I haven't broken anything. I've got a little problem here. Line 16, yeah, it's not going to be happy with that comma, is it? That's okay. Let's just print the payload. That's fine. And let's see, what have I got? Oh, I didn't call it, I called it bytes in here. Okay, so there we go. That's probably what was wrong with the comma. It appears to run, and I'm getting streams. Okay, so that does work. We've just abstracted it out so that now if I add in UDP or anything else, I could just call that same function. And that means that if I want to change how this function behaves, that's a pretty simple thing to do. Let's think about what I want to push out over this. Let's push out the originator, the respondent, and the port numbers that are in use, in addition to the bytes. So let's send those as our data. And I think that, let me just take a peek up here. Oh yeah, that's actually what I'm sending currently in that event. So that looks okay. Let's get that back on the screen so I can see them both. There we are. And let's see if I can send that out. So to do it, it's going to be broker publish. So this is what we were working on the last time. And it's going over TensorFlow /content. And I'm going to send it, what is the name of, what am I doing here? The event is called content. So that's the kind of event I'm sending, or what the event is, content. That goes here. And then I just have to give it the things that I'm sending. So that's going to be the ID $orange H, C $ID $orange P, C $ID $resp H, C $ID $resp P, and bytes. That really should be all that I need to do. Now, we're going to give that a shot. Let's see if this still runs. It does still run. And of course, you're noticing that we do not still have output. But the reason we don't still have output is that hopefully now that output is being sent over this Zeek channel. Now let's just have a quick look here at comms.py, which is just that same code and should just print the data out. Let's actually try that. It says it's connected. See if we can cause some data to go by. Oh, there we go. Okay, I was getting concerned, but there it is. So now we can see here's the originating host, port, destination host, destination port, followed by the bytes. So there they are. That part's done. At this point, we have managed to get our Zeek to stream data, stream the beginning of an application protocol over to Python. What's next? Well, the next part we have is over on the Python side. I mean, we've captured it, but we should probably clean that up a little bit. So I think what I'm going to do, I did create this comms.py, which was a copy of that other code. But what I'm really going to do is work over here. And in this one, so I'm going to leave that Zeek running. I shouldn't really need to make any changes to it. But at this point, let me just restart and run all cells. But this should be the same code and should successfully connect. There it is. And should begin to produce some data. Now, of course, again, we need to have some new connections here. There's a new connection. There we go. So it is working. So I'm going to interrupt that kernel. All right. And let's start by starting to pull this data apart, because right now I am just printing everything. I'm printing the tag that came in along with all of the data. Let's pull that in and use it as actual data. That feels like a pretty good thing to do. So in order to do that, I should be able to just pull this data out as a tuple. Let's try that. So instead of printing it, all I need to do is say, well, let's see, what were my fields? So I've forgotten the names of my fields. I've got them, let's see, this is not the same anymore. So let me cat out my, what is this, comms.zeek. Here it is. So here are the order of things that are appearing in there. Let's grab that, just copy it. And let me just paste that in right here. And of course, those things are not the right type and that Zeek code and all that stuff. However, I should be able to grab those things. So I'm not going to call it the originator because I know that in Zeek, we tend to think of things in terms of streams, but I'm going to be a little bit sort of packet-centric here, because that's really what I'm grabbing at this point is packets. And I'm going to say this is the destination host, and this is the destination port, and then I should have the content. And that should be equal to that. So if all goes well, I should be able to print, say, content, and that ought to work. So let's just see what happens here. Let's get it connected, and I'm going to trigger some content in another window here. And no output. Oh, okay, there it goes. So I wasn't seeing anything right away, but it was running. Probably I was having some buffering going on inside of Jupyter there, but absolutely that content comes out. Now I have broken those fields apart into their Python equivalent. So that's pretty handy. That's a pretty easy thing to do. And I personally prefer to break them apart like that, though there's no reason why you couldn't use, say, a list comprehension and turn them into a list of things, or maybe do a dictionary comprehension dealing with the names. And I'm just going to deal with it like this. It's just easier to grab it like this. Hello there from Panama. Nice to have you. So that means what we have so far is the ability to grab the initial payload from the beginning of the stream from TCP connections, from clients to servers. We've now got it over here in Python. And what I want to think about doing now is starting to think about how I can work with this for machine learning. And that's going to introduce a little bit of complication here. So I think what I'm going to do is maybe up here, let me just split this cell, and we're going to start writing some additional code. Because what I'd love to do is take this ASCII data and turn it into something I can use as features in machine learning. So how many of you have experience in doing machine learning? Have you done anything yet? What kind of things have you built? Have you done anything at all? One of the huge problems I see that people have is they maybe start learning a little bit about it. Maybe they do a couple of tutorials, and the tutorials all work great, though there's very little explanation about why you're doing things in a particular way, but the tutorial works. And then you try to turn your attention to a problem you actually have. Like here, I would like to classify these packets. I'd like to know what these applications are. How do I take what I learned and translate that into the problem I have? That is a really common problem that people face. That's actually why I wrote that Sec 595 class. That's pretty much what we do for the entirety of the class. Well, let me just give you a little insight here. So something that I need. In order to be able to process this using a deep learning neural network, which is where we're heading, I am going to need to turn these payloads into vectors of data. That sounds really fancy, but a vector is really just an ordered list of things, or for us, an ordered list of numbers. That's all it is. And to be more specific, they need to be homogeneous vectors. And what I mean by that is they have to all be the same size, the same shape. So if I'm looking at the payload coming out of my packets here, out of my sessions, I need to decide how much payload I'm going to use, because different packets can have different sizes in them. So is there some minimum size I'm willing to use? Is there a maximum size? We're going to need to make some decision there. And I think I'm just arbitrarily going to say, let's use 32 bytes. Let's just pull that number out of the air, 32 bytes. So I think I'm just going to, create a little define for me here. So max length is going to be, length is going to be 32. And that's just number of bytes of payload to keep. Payload to keep. Okay, great. That's going to allow me to make them all the same length, unless, of course, they're shorter than that. Well, we can solve that problem too. So to make it shorter than that, or to deal with something shorter, we could just pad it out. And what could I pad it with? Well, it turns out that the padding won't matter, because as long as I pad the same way, it just doesn't matter. So let's start trying to fix this problem. I'm going to define a function I'm going to call content to features. and it's going to take input data. And I'm going to say that it's also going to input a number of bytes. And I'm by default going to say that that's max length. So if you're not super familiar with Python, when I'm passing in these arguments and I do this here, I'm effectively making this an optional argument. And if you don't tell me what to use, I'm assigning it whatever max. Oh, I've still spelled that wrong. I tried 3 times. Max length. There we go. I'm assigning it whatever max length contains. Now, listen, I know there's a whole bunch of you watching. If you see me doing something like that and I mistype something, please feel free to speak up there. So can I customize the vector, or do I need it standardized for some integrated parsing tool? Well, we are customizing it. It's not a matter of having to have some special parsing tool or something like that. It's much more that when we're using a deep learning neural network, I need to know exactly how many features there will be. And for us, the features are going to involve the stuff that's coming out of the packets here, the bytes, or maybe the bits that represent them. So I need to have them all be the same size. I've arbitrarily picked 32 bytes, and that's all I'm enforcing. But I can customize that to anything I want to. Well, we can make it 1,500 bytes, 2,000 bytes, 40,000 bytes, 100 bytes. It doesn't matter. I'm picking 32. Now, you may be asking, well, what's your reasoning on that? Well, think about it. If you think about how application protocols work, take DNS, HTTP, TLS, NTP, you name it. When we have an application layer protocol, there will be a header. And, as the name implies, the header will be at the front of things, at the head of the data. And those headers tend to be on the small side. If you think about TCP, for example, the TCP header must be at least 20 bytes long. If you're looking at IP version 6, that's going to be a 40-byte header. If you're looking at something like DNS, it's got, let me just think here, 2, 4, 6, 8, 10, 12, 12-byte minimum length for a DNS header, 12 bytes. So I'm trying to pick a number that's going to be big enough to be able to capture pretty much any application header that comes along, but I don't want it to be so big that I'm now trying to do my categorization based on stuff that's just effectively random data or things happening within the protocol. That's kind of how I'm balancing this out. So I hope that answers your question, Francesco or Francesco. If it doesn't, do let me know. But I'm going to accept or take this data, and let's do a little manipulation on it. Let's first do this. Let me say that my, let's see, I'm going to call it X. X is going to be the data that I'm given left justified by the number of bytes. Now, I could just put number of bytes here, number of bytes, comma 0. I could just do that, but I want to just point something out to you. What I'm looking at here and seeing as hex is actually ASCII hex. In other words, that really isn't the number 0x16. Those are the ASCII 1, 6. So this is just a string. If I were to base this on the number of bytes or left justify on the number of things in the string, right now, that string is going to be those ASCII values. And what I really want to do, I want to make sure that I have 32 bytes left after I decode them back into integers. So I think what I'll do is instead say number of bytes times 2. Because when I render this hex out as ASCII, it's going to take up twice as much space. So that should mean that if I'm asking for 32 bytes, it's actually going to allow a string that's 64. And if it isn't that long, it's going to pad it with ASCII zeros. That makes sense because we're dealing with ASCII right now. But I also need to make another little change here. I'd also like to say that X is only going to be a maximum of number of bytes times too long. In other words, I am both expanding it out if it's too short, and then I'm saying, all right, but if it's too long, we're going to cut it off at those 64 characters. Now, if I do that, let me, instead of printing out content, let me print out content to features content, and let's just restart and run all. Fantastic. Now, Zeek should still be running in the background. I did see some stuff happening back there. Oh, yeah, that was nothing. Sorry about that. Let me just bring this back up top. And I've got some none. That's interesting. Let's try to go somewhere in a browser and cause some data to be created. All right, it does still seem to be running. I might need a little more data. Get another tab up here. Let's just go browse some Google News here. All right, come back down. Oh, okay. So we have managed to break something. Oh, I can see what we've broken. Can you see what's wrong here? Can you see what's wrong here? So I am printing out content to features, but unfortunately, content to features, it doesn't return anything. So that's going to be a little bit of a problem. So let me return X out of that. X. I'm getting my mind confused now because I'm working with a C-like language and with Python at the same time. Let's restart that and run all cells. It once again says it's connected. It's grabbing the data again. Let's again browse to a news article here. Ah, there we go. So that is working now. So let's interrupt that. I have now successfully gotten that data back over there, and notice that they are now limited. I'm going to, trust me on this. If we were to count that out, that's going to be 64 characters, or if we look at it as hex, 32 hex bytes. 32 hex bytes. But I don't need ASCII. Now, sort of an interesting thing here, just as a quick aside, since we're going to do the machine learning, it turns out I really could leave it as ASCII data and do the learning just based on the ASCII data. I personally wouldn't do that, but that should work. It may not learn as well. It may take a lot longer to converge or find a solution to the problem, but it should definitely work because all of the data will still be represented in exactly the same way. But I feel like I should really turn that back into bytes. I should really turn it back into numbers. So how can we do that? Well, how about this? Let's create an array here. I'll call it byte values. It's going to be a list, and I'm going to say for I in range 0 to the length of X 2. Now, I'm sure that pretty much everyone on here who's ever done anything with Python, I'm sure you have done for I in range something. But you may not have run across this one. So the 2, what I'm doing is I'm setting what the iterator is. So it's going to start at 0, then 2, then 4, and so on. So I'm telling it to increment by 2. Why am I doing that? Well, remember, this 1 is the high order nibble of the first byte, and the 6 is the low order nibble. I really want to pull those two things together so I can access both of those things. So let's do this. Let's say byte values append. So we're going to add to this list the byte value. So I'm using CHR, which is going to take or turn something into a byte value. It should do that for me. The byte value, another closing parenthesis here, of the integer value of the x from offset I, wherever you are, to I plus 2 as a base 16 number. And then let's return byte values. So let's run that. Let me restart, run all cells, and let's talk about that. And maybe we'll get lucky and get some output here while I'm talking. So what's this? X sub I colon I plus 2. What I'm trying to do is grab the next two characters, the thing that's at offset I and the thing right next to it. Now, this is kind of a kooky thing about Python. Oh, and I can see down there it's working. This kooky thing is when I'm specifying an offset, it is used as an offset and everything is zero-based. So, okay, X sub I makes total sense. But then I get to say where I want it to go to. And that's the part that's a little bit weird, at least to me, because I don't give it the offset I want it to stop at. I have to give it that offset plus 1 because it's actually going to stop one space before that. So if I said go from I to I plus 1, it would still just give me the thing at offset I. But by asking it to give me the thing at I up to but not including I plus 2 as a hex value, you can see here it has successfully pulled out a hex value of 0x16. Wow. Now, I'm going to do one last thing. I'm going to do it pretty quickly here. Let me just interrupt this thing because what I have right now, I have these bytes. And they're represented as bytes. They're in this array, these bytes. I'm thinking way further ahead because, you know, in our next live stream, I think we are really ready to start turning this into a neural network. And I know we're 2 live streams in. We still haven't even imported TensorFlow. What's the deal? Well, if you haven't worked in machine learning or data science before, let me tell you, the thing you spend the vast majority of your time doing is just pre-processing your data, getting the data, cleaning the data, pre-processing the data, understanding the data, and then turning it into the network. Turn it into the network, that's going to be minutes. But all of the other work, that's a lot of upfront activity. There's one last kind of processing I want to do because we've got the bytes, but I'd really love to have them as bits. Really love to have them as bits. Why bits? Because in the end, if I'm looking at an application layer protocol, take a DNS header, there are bits in there that mean things. Sure, there's bytes that mean things like how many questions were there and how many answers were there, but there's a bit that indicates if it's a query or a response. There's a bit that indicates whether or not recursion should be used. I want to be able to find those, or let me say it another way. I want for my neural network to be able to find those the most easily. So I don't want it to have to learn that an 8 means this, but if it's anything less than an 8, then the query's turned off. I don't want to have to learn that. I want it to be able to see the bits. So I'm going to turn this into bits. To do that, I'm going to create another list called bits. I'm going to kind of brute force this. I'm going to say for byte in byte values. So for every one of those, I'm going to do bits.append, and I'm going to nest some or do sort of a more complex list comprehension here. So my list comprehension will be this. I'm going to say I would like to do the ordinal value of byte ended with 1 shifted left X number of times. Well, let me use I number of times, and then that whole thing should be right shifted I times. And I will explain all of this in a second. Let's see. I think I'm actually okay on parentheses here. I number of times for I in 7, 6, 5, 4, 3, 2, 1, and 0. Okay. And got something going on here. Let me just see here. So I've got some unbalanced parentheses. So I'm opening one, open two. There's one open, two closed. Why is this not happy? There's something unbalanced here. I just don't see where it is. If you are seeing what I have not balanced, please do let me know. How unbalances that for I and oh, I'm missing the closing bracket on my list comprehension. There we go. So that looks good. And then I'm going to return bits as the result. So let me kernel, restart, and run all. And while that's talking or thinking, let me just explain this. So in order to convert this into bits, here's what I've done. I'm asking it to take every value of byte. For each value of byte, I'm going to ask it to AND that iteratively against I. So what's I? I is going to be the number 7, 6, 5. So the first pass through is it's taking the number 1 and shifting it left 7 bits and ANDing it against this byte. In other words, it's turning everything off except the high order bit. It then shifts that back to the right 7 bits, so it's now in the lowest position. It then does the same thing for 6, 5, 4. So it's effectively just pulling off each of the bits that makes up the byte. And you can see down here, I now have a list of lists that has all of the bits that make up my data. In fact, we could even do just one last thing. Let me do this. Let me import NumPy as NP, and this is going to be the very last thing we do today. And let's see, what I'd like to do is return, I'm going to return a list of NP array of bits as type np.uint8 flat. All right, so let me rerun that and explain what I've added in there. Again, I am thinking ahead to this idea that we are going to be turning this into a neural network. I'm going to need to process this data out. Right now, I've got a list of lists of bits, but in the end, I don't really need it organized that way. I can make this a much simpler structure and just turn it into a stream of bits. I would also ultimately like to turn that into a NumPy array, because that's what I'm going to use within TensorFlow or pass into TensorFlow for features. So I'm asking it to take those bits, convert them into an array of type unsigned integer, 8 bits long, and to then flatten it. And by flattening it, I now have, that's a single application layer being delivered to me there. I now have all of the bits being returned to me as a single list for each stream. And here are all of the streams. So now it's going to be much easier to just turn this into something a network can handle. Wow. Well, that's going to bring us to kind of the end of what we're going to cover today. I know it was a lot of ground and maybe not the clearest, because there's still all this stuff happening under the hood. It's kind of this back-end work we're doing so that we can then turn it into something I can process with the neural network. And processing it with the neural network, that's the thing we're going to do in our next session. We're going to start out by building a really simple neural network and just seeing if we can do some basic classification. But then we're going to build a more complex structure and introduce the idea of a thing called an autoencoder and how I can use that to measure some reconstruction loss. So I can decide, is this TLS or is it, say, DNS or any of a variety of different protocols? There's a little something I'm going to do in between. I'm going to go out and I'm going to create a whole bunch of training data. And I'm not going to make you sit and watch me do that. I will explain what's happened for that and provide the script as well I'm using to generate the training data. It's actually these scripts here, a little tinkering, so that we have some data to train on. Well, I need to have some real data to work with. Now, I really do appreciate you being with me today. I know it was a lot of ground to cover. Next time, it's going to be really amazing because we're going to get some learning done and begin to see some outputs and see how to make this something live or be able to begin to make it live in our Zeek cluster. Now, that's actually going to be 2 episodes from now, really putting it in the cluster. But next week, we'll have that network working, or the next live stream. If you do have any questions or anything, I'll hang out for a little bit and be available in the chat channels. Otherwise, thank you so very much for coming. Please tell your friends about this. If you've got people who are interested in Python or TensorFlow or Zeek or network monitoring, people working in a SOC, send them a link to this next live stream and maybe the series we've done so far. I'm also, again, open to any suggestions you have for future live streams. I've actually got a series of ideas that are taking us out through October. But if you have additional ideas, put them in the chat here, or please do feel free to maybe send them to me over LinkedIn and hook up with me there. Now, I do see Mohammed's asking me, can I use random forest in order to do the classification? You absolutely can. I'll tell you, though, I'm not going to use random forest for it. The reason is that random forest in the end is going to want to classify it as a thing. And while I could use random forest to try to classify lots of different protocols, I'm not sure that's going to be the best fit for this. I'll tell you what, though, Mohammed, you've got me thinking that might actually be a really interesting comparison. So how about this? Maybe the next live stream, maybe, or definitely the live stream after, I will absolutely take the time to redo our classification piece using random forest. And we've got to compare one against the other and see which one seems to have a better performance overall. I sort of suspect the neural network's going to end up winning because I can easily continue to train it on new protocols, and that random forest maybe isn't going to be the best thing to use, but we'll try that out. I hope that works for you. So again, if you've got other suggestions like Mohammed here or anything else, hit me over the live stream here in the chat, or maybe reach out to me on LinkedIn. All right, folks, that's going to be it for today. I thank you again for coming. I look forward to seeing you in about 2 weeks on October 1st at 12 noon. We're going to pick up from right here where we left off.